Okay, so today we are going to talk about exponential functions. So to start out, we're going to ignore these first two things and we're going to move on down to this star right here. It says any quantity that grows or decays by a fixed percent at a regular interval is said to have exponential growth or exponential decay. So there is a difference between exponential growth and decay. I'm sure you can assume that growth is going to increase while decay is going to decrease. So we're going to start off by graphing these exponential equations. Now, if we want to graph these exponential equations, we do not know how to graph exponential equations, so we need to do so in a way that we know how to, which is by making a table. When we pick a table of values, we usually start with -2, -1, 0, 1, and 2. That way we get some negative and some positive. What we are going to do is take this -2 and plug it in for x to see what we get. So we take our calculators and we type in 1, parenthesis, 2, caret, -2. If you were to put that into your calculator, you would get that y is 0.25. Then you do the same thing but with -1. 1 times 2 to the -1 is going to be 0.5. And then 2 to the 0 times 1 is going to be 1. 2 to the 1 times 1 is going to be 2. And 2 to the 2 times 1 is going to be 4. So then we go ahead and we graph each of these points. So our first point is -2.25. So we go to -2 and we go to 0.25, which is about right here. Then we have -1.5, so -1 a little bit further up. We have 0, 1, 1, 2, and 2, 4. These graphs are going to straighten out on the x-axis. They are never going to actually touch the x-axis. In this case, they are going to straighten out there, and they are shaped like so. This is an exponential equation, an exponential function graph. So looking at this graph, we see that it is going up. Therefore, this is known as exponential growth. Go ahead and flip to the next page. On this page, we have a different graph. We're going to do the same thing to graph it. We have x and y. We do -2, -1, 0, 1, and 2. And we plug each of those values in to here. So we take 1/2 to the -2 times 1. That is going to get you 4. We're going to take 1/2 to the -1 times 1. That is going to get you 2. You plug in 0, that is going to get you 1. You plug in 1, you are going to get 1/2. And you plug in 2, you are going to get 1/4. If you are unsure of how I'm getting these numbers, please use your calculator. All you need to do is type this exact equation in, but instead of the x, plug in the values that you want to plug in. Now we need to graph each of these points. So we have -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, and 1/4. So in this case, our graph is going down. Again, it straightens out on the x-axis, and I assume that you will be able to figure out that this is not growth. This is going to be a decay function. So, with our exponential growth and decay equations, when we have exponential growth, it is when this number b is going to be greater than 1. In this case, it is going to be decay when b is in between 0 and 1. So it can be 0.25, it could be 1/2, it could be any number that is between 0 and 1. So b is greater than 1, my graph will increase. B is less than 1, my graph will decrease. So just by looking at these graphs, A and B, you should be able to tell whether these are growth or decay just by the way that they look. So if we're looking at letter A, we see that it is going down. Therefore, it is going to be decay. Letter B, we read from left to right, and we see that our graph is increasing. Therefore, it is going to be growth. Now, we can also do this by looking at the equations. We are trying to look at the number that is represented by b, either the number in parentheses or the number that is receiving the exponent. So if we look at letter C, we see that we have 3/2 is our b, and we know that 3/2 is greater than 1, therefore this is going to be growth. For letter D, we have 1.2. We know that this is greater than 1, therefore it is going to be growth. For letter E, it can be a little bit confusing because we have a B, but we do not have an A. When there are no parentheses present, then the number that is getting the exponent is known as your B. So in this case, 2 is our B, and that is greater than 1, therefore we have growth. For letter F, 1/4 is between 0 and 1, therefore it is decay. And letter G, we have 0.5 as our B, and that is less than 1, greater than 0, therefore it is decay. So anytime our B value is greater than 1, it's going to be growth. In between 0 and 1, it's going to be decay. Okay, so the general equation for exponential growth and decay functions. A is known as your initial value. If B is greater than 1, then it is growth. B is your growth factor. And R is known as your growth rate. There are equations that go with each of these in order to find your growth rate. R is going to be equal to B minus 1. That will get you your growth rate. On the other hand, for decay, we still say that A is the initial value. We say that this should be B is between 0 and 1. Then we have decay. B is our decay factor. And R is going to be our decay rate. In this case, decay rate, R is going to be equal to 1 minus B. So for example, if I had the equation y equals 2 times 0.5 or 0.6 to the x, my initial value would be A, would be 2. My factor, my B, would be 0.6. And then in order to find the rate, I would take the 0.6, I would plug it into my formula, and I would get 0.4. So I will go ahead and go through one of these examples, and then we will do the rest in class tomorrow. First, looking at this, you should be able to recognize this growth or decay immediately. You should see that the number is greater than 1 that is inside the parentheses, therefore it is growth. The initial value is always the A, the number in front of the number getting the exponent. That is going to be 3 in this case. The factor is the number in the parentheses, or the number that's receiving the exponent, and that is going to be 1.8. And because this is growth, we go ahead and we look up at our growth formula in order to find our rate. It says R is equal to B minus 1. So we take R is equal to B, which we said was 1.8, minus 1, which gives us 0.8. And we will go through more examples in class tomorrow.